Okay. 8, we're getting close to the end. This problem is kind of like the opposite of all the problems we've done. You can clearly see this is that overlapping similar triangles, um, but here they're not telling us they're similar. They're not saying, oh, they're similar or parallel. They're asking, hey, explain why this base of that small red triangle must be parallel to that base of the bigger blue triangle. And well, they're only parallel. They're only parallel if this red triangle is similar to the blue triangle. Well, if they're similar, then sides are proportional. Okay, um, and you can show that. So that's how we're gonna show and explain that those sides are parallel. Is we're gonna show that the sides are in proportion, thus meaning the triangles are similar, thus proving that those corresponding bases have to be parallel because the bases of similar triangles must be parallel after a dilation. It's property. So let's go do this. All right, let's see. A lot's already given in that picture, but let's just read to make sure. Yeah, point A, B, yep. That's just, telling us they're there. All right, I got that AE in there. I got that AC is there. Yep, everything's there. Okay. This is a great problem for Alyssa's method. Alyssa's method was you got these two pieces. See how it makes that V shape? You can compare that to these pieces. And the reason why this works is you're just taking that entire blue triangle and you're saying, look, these points, they're going to split those sides into equal ratios, into proportion. So, because we're not like mixing, we're not viewing it as like this red triangle anymore compared to that big old blue one. Now we're just saying, oh, that blue triangle, this side is getting split up into two pieces, and the corresponding side, this one over here, is getting split up into corresponding pieces, and those pieces have to be proportional. Like this red side can't be longer than that other red side, and vice versa with the green. So that's why Alyssa's method works, and why this is a great problem for it. It just makes it easier. So I'll do it her method, and if you want, I'll do it the other way. I'll save it at the end. But we're gonna do uh, 3.75 over 4.5, and we're going to do 5 over 6. And all I'm trying to demonstrate is that these are equal ratios. So I could show it with a proportion. I can cross multiply, and I can be like, well, 3.75 times 6, that equals 22.5. And I bet you when we do 4.5, the other butterfly multiplication, that's also 22.5. So you're just showing that, hey, this is proportional. Okay. And not only can you show like that, you can also just say, that red fraction, 3.75, that ratio, that ratio is going to be equal to that green ratio, 5 over 6. They're equal ratios. All right. You can say it that way. But no matter what, the way you're going to explain this is you're going to say, AB is parallel to CD because the sides are proportional. That should be sufficient. I would probably go a little bit further. I don't know. Let's look at the answer key. 8. What are they saying? 8. Yeah, that was enough. They're doing a different ratio, but AB is parallel to CD because AB divides sides proportionally. Okay, that looks good enough. The other way we could do it is we could say, so if you buy that, you can stop the video and be done. You could do it the way we've been doing it. That red triangle with like 3.75 and 4.5, and then you could view this as a big old blue triangle. And this side is 3.75 plus 5, so it's 8.75, and this would be 10.5. And you could make a proportion out of that. 3.75 divided by the corresponding 8.75, or you could just divide the reds and compare it to the blues divided. But I'll do it this way: 4.5 divided by corresponding blue side, 10.5. And you're going to see that those things are equal. And I'll just divide the ratios. I'll do 3.75 divided by 8.75. You get that weird decimal. And then 4.5 divided by 10.5. That's going to be the same weird decimal. Yeah, same weird decimal. That might even been what they had. But with these problems, you just really want to use that proportional word. And if you're feeling uncomfortable, go back to similar triangles. Just tell them that, hey, the triangles are similar because the sides are proportional, and then you can weave that back to, oh, if the triangles are similar, then corresponding sides of similar triangles must be parallel. All right, so we want to elaborate. So triangle AEB is similar to triangle CED. Therefore, their bases must be parallel. And you already told me the bases. And maybe you just want to modify that. You'd be like, base AB is parallel to base CD because the sides are proportional, and so on. I'm rambling, but that's okay. See you in the next one.